In the AUTOSAR standards, the main element of the software architecture are the software component. But how big or how small should they be? Today I'm happy to meet my colleague Markus here in my hometown, Paris, to talk about this topic. Welcome to Paris, Markus.
Thanks, Nabile. And it's not only your hometown, it's my former hometown. I've been living here for 5 years, so super excited to be back. And to your question, yes, the AUTOSAR standard standardizes the elements of the software architecture, but it does not standardize the size, the granularity. So how do we deal with these degrees of freedom?
So with this freedom, it means we could have one ECU with one big software component, or probably thousands of software components with just one line or two lines of code. Is it possible?
Yeah, I mean, both of these extreme examples would be compliant to the standard, but there must be some sweet spot in the middle because both are not efficient. So how do we find this sweet spot? What are the questions we have to ask?
Yeah, good question. So for me, question number one is probably the topic of distributed developments, because the projects are complex, the software we develop are complex, so different engineers work together. Especially in model-based project, we see that one software component corresponds to one Simulink model, and this means that if different engineers need to work together, they need to have their own software component for the implementation.
Yeah, true. And second, number two, I would say, is reuse. I mean, the AUTOSAR standard was really invented to enable reuse, to have software components which are independent from hardware architecture. So what's the right size of the runnable so that we can, and the software components so that we can independently reuse them? If they're way too big, then probably this will become a challenge.
Yes, this is a good reference. And there's a third one in my perspective, which is the design for testability. So yeah, definitely. So especially you will typically have one tester for one software component. And if the size is too big, then this is probably a lot of work to achieve sufficient coverage, dealing with many interfaces and so on. And sometimes we see software component with one or more runnables. We could also imagine that one runnable is one unit which can be developed and tested per engineer.
Yeah, totally. And one more thing I think we should address, because often we hear people say, oh no, we have to make big runnables, big software components, because we are afraid of the high resource consumption that it is introduced by RTE communication.
Yes, and sometimes we even see that there's additional sub-function introduced in the runnable just for this purpose. I mean, that's probably not...
I have two thoughts about this. Yes. The first one is, the RTE communication is not that resource heavy as some people might think, especially if we talk about the standard sender-receiver communication. The RTE write and the RTE read call, they're actually not function calls. They are mostly in the actual production RTE implemented with macros, so defines. So in the end, it's really just the direct and read-write access to a global variable on the object code level. So that's pretty efficient. Plus, I think, again, talking about this reuse aspect of AUTOSAR, one nice thing about the AUTOSAR standard is that with the communication handled exclusively via the RTE, we have a nice built-in mechanism to avoid naming conflicts. And if we start creating internal structures inside of the runnables, which have artifacts with global scope, including functions and variables, then we are sort of working against this principle and introducing potential problems which normally the AUTOSAR standard tries to avoid.
Indeed. So thanks, Markus, for the clarification. We hope you enjoyed this video. Please give it a like and follow us on LinkedIn and YouTube for more videos.